Millions of people around the world search for answers to humanity's origins by typing one word into Google: Anunnaki. Ancient alien theorists suggest that advanced extraterrestrials came to Earth and modified human DNA, creating us in their image. It's an idea that has fueled books, TV shows, and YouTube rabbit holes for decades. But what if the truth is not above us but beneath our feet? What if our DNA was not rewritten by gods from another galaxy, but by the Earth itself, through fire, gas, and time? And what if the agent of that transformation wasn't a spaceship, but volcanic sulfur? Let's start in East Africa, the cradle of humanity. 3.2 million years ago, Lucy, Australopithecus afarensis, walked upright across the Afar region in Ethiopia. Just miles from her discovery site lies Erta Ale, one of the planet's most active volcanoes. Geological records show that this region experienced intense volcanic activity between 3.8 and 3.4 million years ago, directly overlapping with Lucy's time on Earth. These eruptions didn't just blanket the region in ash, they filled the air with sulfur gases, particularly sulfur dioxide and hydrogen sulfide. While too much sulfur is deadly, small, repeated exposure acts like a training ground for life, forcing organisms to adapt and activate internal defenses. Fast forward to Latoli, Tanzania, where we find 3.7-million-year-old hominin footprints preserved in freshly fallen volcanic ash, from eruptions that came just days or weeks earlier. These weren't just fossil sites, they were living laboratories, where early hominins walked across sulfur-rich earth, breathed the gases, and learned to thrive in chaos. Move north to Olduvai Gorge, where both Homo habilis and Homo erectus fossils have been discovered. The site is filled with distinct volcanic layers from nearby Ngorongoro volcanoes. Early humans here not only survived but advanced, using tools, building shelters, forming groups, all while living in a region reshaped by eruptions. Even Homo sapiens, our own species, appears during a period of intense Rift Valley volcanism around 300,000 years ago. In places like Jebel Irhoud, Morocco, and Bodo, Ethiopia, eruptions weren't anomalies, they were part of the landscape. This timeline doesn't stop there. The Toba supereruption in Indonesia, around 74,000 years ago, was one of the largest volcanic events in human history. It released more than 100 times the sulfur dioxide of Mount St. Helens, causing a global volcanic winter. Human populations dropped dramatically, but those that survived evolved new genetic markers, particularly in East Africa and South Asia. Could sulfur have been the pressure that shaped that change? So what makes sulfur such a critical part of this story? Sulfur is essential to life, but in the right amounts, it's also a stressor, and stress is a major driver of evolution. Let's break it down simply. Cysteine and methionine, two of the building blocks of protein, are sulfur-based amino acids. They're critical to maintaining the structure of DNA repair enzymes. Glutathione, a sulfur-containing antioxidant, protects cells from DNA damage caused by toxins, like volcanic gases. S-adenosylmethionine, SAM, a compound built on sulfur, regulates DNA methylation, a process that turns genes on and off, especially under stress. Methylation can cause inherited changes without altering the DNA sequence itself. This is called epigenetics. When early hominins were exposed to low doses of sulfur gases in volcanic regions, their bodies were forced to adapt. Over time, the genes that helped them survive these harsh environments, genes related to repair, resilience, and metabolism, were passed down. And generation after generation, these survivors weren't just scraping by, they were becoming more complex, more capable, and more human. Now compare that to the Anunnaki alien theory. It says that an advanced race came here, modified our DNA, and left. But there's no physical evidence, no alien tools, no spacecraft, no unexplained technology left behind in the fossil record. Instead, we find layers of volcanic ash. We find hominins buried in sulfur-rich sediments. We find genetic adaptations that match environmental stress, not advanced design. This is nature's lab, and the conditions, volcanoes, sulfur, survival pressure, all point to a biological, earthly process. In other words, we weren't created by distant beings. We were refined by the Earth itself. Let's be real. We want to believe in the spectacular. Aliens are exciting. Volcanoes, not so much. But if we're seeking truth, not fantasy, the volcanic hypothesis holds more weight. It explains how stress reshapes life. It explains the timing, the locations, and the chemical tools. It shows that evolution is not random. It's responsive. And maybe, just maybe, that's how God works. Not with flying saucers, but with fire, with ash, with sulfur, with a planet capable of creating life and shaping it. Next time you hear someone say we were engineered by aliens, ask them, why do all our ancestors come from volcano zones? Why are our genes shaped by stress, not design? Why is there zero alien evidence and mountains of volcanic ash? The answer isn't out there, it's right under our feet.